It just tells that looking at all the greenhouse gases, we'll try to like grade how to quantify them. Looking at carbon dioxide as a standard. Now, with reference to carbon dioxide. Now, if carbon dioxide can retain this much heat, if you compare it to other gases, how much can you compare the capacity to retain heat? Okay. Now, if it is assumed that carbon dioxide will retain with unity, that's 1. Then, if we compare it to others, so that's what is used as a base to measure the global warming abilities or capabilities or potential of every other gas. So it is assumed that measuring that potential is comparing with how much carbon dioxide can do. So if you look at that, you'll discover that this is what you normally see. Okay? You'll see that the contribution from carbon dioxide is 1. If you compare that with methane, it's about 25. Nitrous oxide 296, and the HFC or CFCs, the chlorofluoros, will contribute as much. Okay, so that's what that means. I'm believing that you must have looked through this. That's why I'm taking the this maybe a bit hurried discussion to it. Now, if you look at the screen you have here now, if you see the global warming potentials, that for carbon is 1, right? Just like you saw in the table behind, you will notice that methane is next as it pertains to heat capacity or global warming potential. Nitrous oxides and then the fluorinated gases are next. But if you now look at the pie chart there, the pictorial chart there, what do you see?
Carbon had the highest. Carbon dioxide had the highest.
That's how much of it is emitted. So why do you see an inverse?
I am trying to understand, sir.
Okay, you're trying to understand. You see that the amount of carbon in the atmosphere, carbon dioxide in the atmosphere, is far more as compared to the other ones.
Okay.
So their contribution to emission, the emission of carbon dioxide is plenty because the sources are mean. What are the sources? Even plants. No, yes. Human beings, sorry. Human beings.
Human beings who have natural and human cause.
Good. So you see that a lot of human beings are producing carbon dioxide. So you can see that the emission of carbon dioxide in the atmosphere will be plenty. But if you compare to methane, for instance, in Benue or in Plateau or in Abuja, you will not expect so much of methane emission. Why? As compared to the Niger Delta. Because we believe that glass flaring in the Niger Delta will contribute a lot. Okay? So,
yes, sir.
If you are talking about the warming potentials of the gases, it takes the inverse. The more the emission, the less the global warming potential. And I believe that's why carbon dioxide was chosen, okay, as a standard, because its warming potential as compared to methane is very low. Okay?
Yes, sir.
So if you are talking about contribution as emissions, that's the difference. Okay? The emission of carbon dioxide is more, but the global warming potential is what? Far less as compared to the other ones. So if the reverse was the case, that means the whole earth would have burnt down by now.
Honestly, because of the quantities emitting.
Exactly. Okay, so what are the major effects of global warming? Increased air temperature. We know about that one, right? We know that as much as 1 to 3 degrees increase in temperature. Okay? If we compare, for instance, in Jos, how cold it used to be before. may not be as much as that because the earth is warming up, okay? So warming of ocean surface waters. You know, if you go to the Arctic or the Antarctic regions, or that's the polar regions, before there are some water bodies that are iced. But you will notice that those surface waters are no longer iced again, as much as they were. Frost free. Maybe things like, how do you call them? Mm, Snow is not as much as
Yeah.
before again. Then rain patterns have changed. That's changes in precipitation, more droughts, and heat waves. You know what heat wave is? Increase in temperature.
Temperature, yes, sir.
Yes, exactly. So those things are increasing. Hurricanes are extreme stormy conditions. They are becoming stronger and more intense. What do you think would have caused that? You know, global warming would be as an effect, as a reason from deforestation. And when you know when there's deforestation, what did I call trees the other day? They are windbreaks, right?
Yes, windbreaks.
So all the windbreaks are not there. What happens? You expect the storms to be stronger. Then rise in sea level. I told you that moving from solid to liquid to gas, volume
It's
increases,
occupying
right?
more space. Yes, sir.
So when the ice is melted, of course you expect the sea level to rise. Flooding and erosion, natural ecosystem and wildlife depletion and all of that. Decline in agricultural productivity. You will notice that the productivity of even the soil from agricultural activities has reduced. Okay, and
Yes,
then there's
sir.
more likelihood of the polar regions to give ice-free conditions. Now, this is just a graph that shows the sea level as how it rises with respect to time. That's years now. You see that compared to from 1998 to 2016, you can see how much it has risen. Okay.
Mm.
Mhm.
Yes, sir.
Mm. Then, what are the various emissions? You see carbon dioxide and their attendant problems. They are all outlined here. I guess you must have looked through this. We've spoken about that. We cannot really, if you want to reduce carbon dioxide emission, you cannot get rid of it, but you can reduce from our anthropogenic activities, and which we know that greenhouse effect as mostly as a result of anthropogenic activities, right? So if we
Yes, sir.
mind the way we behave, we can now reduce them. Then this one just spells out that, with our understanding of this now, even in this class, we can sit down and say, okay, let us have a meeting as a class now and decide that, okay, we have come to understand that this is a problem. So let us, what are we going to do to curb this problem? Okay. So as nations, they met in Paris in 2016 under the auspices of COPs, and they made some agreements deliberating on how to reduce the effect of the greenhouse effect, carbon, what do you call it, global warming and climate change. And so to achieve this, they said they wanted to reduce the increase in temperature to below 2 or even 1.5 degrees. I said that it has gone as high as 3 degrees, right?
Yes.
Uh-huh. And what does that mean? It means that not that it's going to stop there, that with time it will still be increasing. So these nations have decided to sit down and say, okay, we want to beat this thing down to lower than 1.5 degrees. Okay. Uh, mhm. So you must have read through the agreement. Then, apart from that, they decided that some countries, I don't want to be very critical this morning, but some countries decided that they will look at their nationally determined contributions of emissions or whatsoever. I don't know. Nigeria was part of it, but let's see how Nigeria has fared so far. And then they decided that they are going to have low greenhouse gas emission development strategies. Okay. So, and apart from that, they had enhanced transparency frameworks. that starting from 2024, countries will report how they are faring as it pertains to all the agreements that they've made. So from time to time, that was 2 years ago when they went for COPs again, they now presented their own, how much they're doing as it pertains to reducing that. And then a report of that came out in 2021 as well, APC. If you take a look at that, you'll be able to see much of that. Let's not dwell on that, okay? But just to tell you that some countries or some nations are deliberate about it and they have sat down and they are making reports on things like this to be presented at their various meetings. This slide just shows us the global emission in 2019 of greenhouse gases per capita. Please, what do we understand by per capita? Per person, right?
Yes.
So now let's look at how much each country generates. Look at China, look at USA, look at Europe, look at India, and then look at Russia. Which one produces the least, generates the least emission of greenhouse gases? Russia, good.
Russia.
Yes, good. Now, when you look at, okay, I think we are accusing humanity as the cause of emission of greenhouse gases, right?
Yes.
So if we want to reduce it, what do you think we should do? We should check our anthropogenic activities, that's the human activities, right?
Yeah.
Yes, sir.
Good. Now, somebody is claiming that, okay, I'm not emitting much. But then one person is emitting as much as 12.5 tons. What does that mean? It means that one human being is emitting so much. So are they really doing well?
No.
As
No.
far as it concerns mitigation, you can see that US is bringing as low as 5,000 metric tons. But per capita is up to like 15. So their human attitudes are not really very well. So I don't think they are doing very well. Okay. So we should know the statistics that actually make sense, not just that somebody is claiming to producing, etc. So Nigeria's contribution, let's look at it. And let somebody, one or two persons speak to the slides. This is Nigeria's contribution. You have looked at this before. So what do you understand by this?
Okay, good morning, sir.
Yes. Simeon.
From my understanding, I see to it that the total greenhouse gases emission per capita per an individual in Nigeria as of 2015 was 1.67. This means each person emits about
This one.
0.998 of nitrogen oxide and 0.26% of carbon dioxide and that of 0.5 tons of carbon dioxide. That is my understanding, sir.
Okay.
But when you combine the total emission of the gases, the total emission of the gases is 1.67 per individual. Then there is a breakdown.
Okay, yes. So, okay, yes, go ahead. Yes.
Okay. What I observe is that from 2015 to 2019,
yes,
you see that it has reduced from 1.6, and at 2019 we're having 0.5. So that's my observation.
Okay. Any other observation? So, Akpan, I can see you want to talk because your mic is not muted. So go ahead.
Yeah, the total emission as 1.67 ton per capita in 2015. Actually, the year between 2015 and 2019, there is a decrease. We have a total of 0.5 trillion per capita in 2019, which represents the emission of CO2 per capita. It's actually decreasing.
Okay. So in the absence of any other thing, let me quickly explain this now. Now you have to take your time and look at it very well. You see that the first thing is the total emission. Okay. So that one is whether we're not comparing with anything. So that's as much as Nigeria is emitting, right? Per capita.
Yes.
Okay.
That's per person.
Yes.
Mm. Let's say all the gases that are greenhouse gases that are emitted. If you check how much of it, the volume, because there are gases, the volume, as compared to the population of Nigeria, each person is emitting maybe 1.6 tons. Okay?
Yes, sir.
1.7, let's say 1.7. Now, if you break down the gases down to methane in the same 2015 now,
Mm-hmm.
one person is emitting 0.9.
Okay.
That's a lot. Okay?
Yes.
Then if you are looking at the NOxes, the nitrogen oxide gases, is 0.1. So you now see that the contributions are different. Okay? Then we'll look
Yes.
now the contribution of CO2 to world emissions as far as Nigeria is concerned is up to like 0.26. There are so many nations in the world now. So for Nigeria
Yes.
to get up to that is still much.
Okay.
How many countries do we have in the world? If you say if there are 100 times 0.2 or 0.3 is what?
26.
No, 0.2.
It's 30.
0.3
It's, two- it's 30, sir.
is 30. Okay.
Yes, sir.
So it goes to mean that just 100 countries are contributing as much as 30, like Nigeria are contributing as much as 30%. And how many countries do we have in this world? There are many. So Nigeria is
Plenty.
a high contributor. Then the emission of CO2 in Nigeria per capita, that's per person, is 0.5. That's high. Now, the good thing is that CO2 is not totally very harmful, but it contributes to greenhouse effect. Okay?
Okay.
So it's
Yes.
something worthy of taking note of. So you remember that NDC that we spoke about during the Paris whatsoever, that some countries decided to sit down and say, okay, from time to time they'll be assessing themselves as it concerns carbon house emission. So this is what greenhouse emission, gases emission. So this is what reports Nigeria came up with. Okay, the target here is 2030. How many years from now? 4 years from now. When they started was 2015. Okay, to 2030. And the base data they picked to get this report is between 2010 and 2014. Okay. So if you take a look at it, you see the unconditional and conditional mitigation objectives. There are some that are conditional. Those things that mitigation just means that you're trying to making conscious efforts to make sure that you are trying to curb away a particular issue. So some of the objectives are conditional and some are unconditional. If you take your time and look through the report, you see the key measures work towards ending gas flaring. For instance, in Nigeria, one of the major contributors to gas greenhouse effect is gas flaring, right?
Yes, sir.
You will see that if you go down to the Niger Delta, you see a lot of gas flaring activities going on. Well, as far as Nigeria is producing oil, crude oil exists alongside natural gas, right? So
Yes,
in
sir.
trying to tap the crude oil, we tap as well the natural gas, and it's not all of you can control. So some is fled into the atmosphere. Okay. Then in trying to curb it, that flaring they burn it. Okay. And while burning, you cannot burn everything, so it is being flared as well. So working towards ending of that should be a key measure to be taken. Then working towards off-grid solar Okay, sorry, my phone was off grid. That's other sources of power generation. That's the off grid. The main grid is the major power supply, which is the public one, the hydro, whatever. So when you go off grid, you reduce the production of pollutants, right? Sorry,
Yeah.
statistics show that in Nigeria, the major culprits in all the sectors about pollution of the atmosphere or the air is from the power generation companies, okay? And the major one in Nigeria is that of hydropower. So off-grid are other alternative means of production of power. And you know, the major off-grid now that is gaining so much popularity in Nigeria is that of solar, right? So if we
Yes.
leave that major grid and go off-grid a bit, we are going to reduce the production of greenhouse gases. Okay? And so on and
So
so
far,
forth. Okay. Yes, yes, yes.
solar is affecting is bringing like greenhouse effect.
Say it again.
Are you saying solar, the emission from solar, the
Eh,
generation of the electricity that now we go to solar, is it affecting is it causing any effect?
Yes. When you say cause effect, it's causing a positive effect.
Oh, okay,
Why do
okay.
I say so? I say so because I said statistically in Nigeria,
Yes.
one of the sectors that is generating a lot of greenhouse gases in
Yes.
Nigeria has been identified to be the power generation industry.
Right.
So in Nigeria now, what's the main source of power generation? The hydropower, right?
Yes, sir.
So if it is contributing to it, if you want to reduce, that means you reduce the activities of that one.
Yes, yes.
But of course, we need light. So you can't say you are going to stop it. So uh, your movement, another example could be this. The more you move from one place to the other, the more you cause pollution of the atmosphere, right? So the major means by which we move is using cars, right?
Yes,
But there are alternatives to using cars, for instance, bicycles and walking. So if we are
yes.
saying that we'll continue moving, but we want to reduce how much pollution we are causing by our movement, we'll reduce the use
Mm,
of cars, thereby using bicycles and trekking. Okay?
yes,
So
sir. Yes,
you
sir.
watch that the key measures to be taken, one of them is working towards off-grid production of power, working towards ending gas flaring, efficient gas generators. It means that there are some generators that they produce a lot of it is from their working instead of them to be producing what we want. Part of it is being converted into pollutant gases. Okay, transport
Okay,
shift
sir.
from car to bus. What does that mean? In this class, if we are 20 of us that are supposed to be going to work the same direction, if all of us use our 20 cars, you can imagine how much those 20 cars will be
Cost.
contributing to this, as compared to all of us hop into one bus. So now it is just
Yes.
one car costing the same. So if you look through it, that's what this thing explains. So between the conditional and the unconditional mitigation objectives, this is a graph that was gotten of how this is. So the black line tells of how it would have been, but the other ones you can see that they are all reduced. Okay. And so, with this foreknowledge of what I've given you now, if you take your time and go through our NDC proposal in Nigeria, you make some sense out of it. I don't want us to dwell much on that.
Okay.
So these are the key mitigating measures. Economic. These are the potential reduction of these measures now. Economic wide energy efficiency. So efficiency is going to increase, okay? And it will reduce the greenhouse gases by so number of metric tons by 2030, okay? Efficient gas power stations. like I said, instead of using those generators that are maybe old and are not giving some, what is efficiency? If output is high, means that efficiency is high, right? But when output
Mm-hmm.
is reduced, means that energy can either be created or destroyed by transform from one form to another. So instead of getting the form we want, we're getting other things that are maybe have adverse effects. Okay, so but the more the efficient, the better the situation. So if we are able to produce with very efficient gas power stations, we'll be able to potentially reduce greenhouse gases by 102 million tons as projected to happen in 2030. Climate smart agriculture. The person in Jos, are you there?
Yes, I'm here.
Yeah.
If
Do
you
you
are not
remember?
talking, mute your mic now. You're disturbing the class. Who is that? Kenu, mute your mic.
Kenu, yes.
Sorry.
Okay. So, Freda. Hello, Freda. Okay, there was a time, speaking about smart agriculture, there was a time some Israeli agriculturists came to Nigeria and chose Jos, and they went and did some trainings about smart agriculture. So instead of using very wide mass of land to just cultivate tomato that you can just gain maybe 20 baskets, you could be able to understand how to do soil fertility and all of that, and then be able to gain as much as, let's say, up to 40 or 50 baskets of tomato using the same thing. So smart agriculture can as well reduce a lot of that. Reduce transmission losses is still about the efficiency of machines that were used. Then delve into renewable energy. The example of using solar systems, like we mentioned earlier, that is how much you can reduce greenhouse effects. So, hello? Do we
Yes, sir.
remember that I was saying that the source of emission at some Nigeria, the contribution,
Yes, you said
electricity at
it's
the highest, that's power. So you will see that.
And
Uh-huh.
also,
So it means that if this is reduced, if this target to be reduced, of course, for the target for electricity to be high means that the statistics of the contribution of electricity is as well high. So, but this is a projection that by 2030, this is the potential rate of reduction as considering the various sectors. Okay, so the electricity sector will reduce more, oil and gas, of course, then transport, land use, agriculture. You will discover that of all of these oil and gas activities in Nigeria, they are plenty, right?
yes, sir.
Mhm. Then transportation, everybody wants to own a car. Meanwhile, there are some developed economies where other sources of transportation are being encouraged. Okay. Now,
Yes, sir.
I know of a city where they were trying to introduce bicycles into the city, and what did they do? So that people will get to imbibe them, they had to do some mouth-watering offers, right? So these bicycles were being locked up somewhere. So you now go there, use your what we call ATM card here. You use it to unlock. Once you can identify that this is an ATM card, of course, you know all our BVNs and our NINs are connected to our cards now. So there's a system that is reading that yes, this is Abu Tenenge unlocking this bicycle. Okay, so it will unlock, but you know it's tied to your bank account. If you misbehave, you'll be charged, right? Now the things they did were you as you unlock it, it's timing you. If you can move from Maraba to, let's say, Guarimpa within 1 hour on your bicycle and then go to the next station and lock it up, you will move free of charge. You will not be charged, right?
Wow.
Yes, you will not be charged, free of charge. So you can imagine a lot of people will go and learn how to ride bicycles, and then those that are smart enough will be able to, like, for the whole month, they will not spend a dime on transportation.
Yes, yes.
Yes. But they were doing that just to encourage people that this is a possibility. So, of course, by the time they launched the main program, maybe they just started by maybe within 1 hour, they'll charge you like 5 naira, which was far less as compared to if you fuel your car or even follow public transport. But what are they able to do eventually? People are still being productive, they'll go to work, but then drastically the emission of gases into the atmosphere from the transport sector reduced. In fact, almost to the barest minimum. You
Wow.
understand? So that means
Yes, sir.
if most people are going into that system, what do you expect?
The
By the
emission
time
will
they do
reduce.
another assessment, they will now get better reduction in emissions. So this is what many nations that are deliberate about these things go back to these COPs and all these other meetings again and report them. And then other countries, I don't know. For we in Nigeria, I don't know. We go there to copy, but can anybody tell me about any program that has been brought up in any way to mitigate any of these effects we've been speaking so much about?
Yes, recently Nigeria to launch carbon credit.
Okay. Tell me more about carbon credit and how effective it can be in Nigeria, or what have you started seeing?
Yeah, on paper it looks good. It's an initiative that will pay you for each amount of this thing, greenhouse gases that you reduce.
Good. I agree with you.
Yes.
What are the potentials? You see the story I just told you.
Yes.
Now you are not there, but do you believe that that is workable?
Yes, it's workable.
A
That
lot
that by
of people that don't even have, sorry for cutting you short. A lot of people that don't even have time to do exercise because of work. At least this is an opportunity for them. They can say that, okay, I expended so number of calories through your bicycle riding, right? To work
yes.
and back. So you are killing two birds with a stone. Or could I even say three? Now, if there's that carbon credit whatsoever, you can still use that when you ride to work. You have reduced the generation of carbon as well, so you can still go and claim money.
Yes.
Aha. So that those are the potentials now we can see. Please build up a case of how the credit initiative in Nigeria,
That's my
looking at
intended.
us, let us be sincere now. How is that going to help us? So, like you said,
Okay.
on
Hello,
paper,
sir.
let's go. Yes, I'm a carbon man, so let's go.
Okay. Yes, actually, what he's saying, I also happen to have a little information about it. Where they now decide to make use of farmers to adopt some certain practices which they will be benefiting from that carbon credit. So the model is in such a way that farmers are trained on some of the regenerative agricultural practices where they ensure minimal tillage, they manage residue, they don't burn them, and as they will continue with this, the level of fertilizer application and use of herbicides also will be reduced. So by so doing, the amount of carbon will be much trapped in the soil. So for each farmer that is able to trap this carbon, they will be paying yearly. They will be paid yearly. So like in Benue State, Nasarawa State, and some states in Nigeria, farmers are now recruited into the program and they are doing it very well.
Hmm. Simeon,
Yes, sir.
typically, we are both Nigerians, we know ourselves. Typically, when these trainings are going on, when you invite a farmer, a typical farmer in Nigeria, the first thing that comes to his mind is first, when he goes for that training, he's going to be fed. We are going to give
Yes.
them transport. Yes, we are going to give them transport.
Yes.
Yes.
After then, except they call for another training, they will go back to their normal practices. I'm telling you. Only that they
Hey,
are doing it on the grounds that yes, one day, hey, they can't give money sometimes. So sometimes they are doing it not because they've actually inculcated the habit, but it's supposed to be
yes.
a lifestyle now. Okay.
Mm.
And
Yes.
now we're
So,
yet to get that right program that will actually draw people into doing that thing.
sir, that is why I'm trying to explain, because there is a particular company now in Nigeria called Toba Innovate. These
Mm.
people, they have trained extension workers
Mm-hmm.
that are going out to villages and onboarding these farmers into the project. And they will remain with those farmers, training and monitoring their activities to see that the farmers keep to these teachings so that they will be qualified for carbon credit.
Mm.
So just as you are saying, the trainings, the company take care of their transportation, take care of their feeding, and they are paying the extension agent heavily on weekly basis to see that they follow up with these farming activities.
The first thing I would say is expensive, right?
Yes, it's expensive
Let's
actually.
let's pray that it doesn't run down that company and then it runs away from Nigeria eventually, because that's the next target now. Uh, that's going to happen. They will run them down, collect a lot of loans, don't pay back, and so many things. Sorry, I'm not being
Just being realistic.
impossible. Yeah, exactly. I'm just being, and I've experienced a lot of that. Our attitude towards a lot of things that benefit us is not good. I
Mm.
don't know whether there's a problem. I tell a personal story of a friend, a childhood friend, that went to the hospital, and because of the relationship the mother had with the hospital people, the clinic people,
Yes.
they treated him. His own health, they treated him well, and the mom gave him money to go and pay and they treat. He went there, he did not pay. He went and spent that money.
Mm.
And so the mother was trying to make arrangements with the hospital people by telling them that if he comes again for further treatment, they should not treat him down until he brings the money. And this young man came and told me that, see, that these people think they are wise. So if it is that money, nobody is going to see that money. Can you imagine your own health?
Mm. Mm.
Ah. So it sounds like it's only him, but it's not only him. That's the typical Nigeria. Let me not say all black men, because some other places things are happening. So I don't know. But we are very quick to blame Tinubu and all of that. Sorry, let's continue with what brought us here. So, in essence, what trying to say, let's recap totally now. We have very good and nice policies, but implementation, as far as Nigeria is concerned, is not very good. And so, what do we think is the advice we will have after having this knowledge of whatsoever on how we can make our own impact now? How I wish we had time. Everybody, I would have loved everybody to speak at this point. But the few people that are led to speak, let them speak, please. In your own way. Just think about it now. Hello.
How we can address the issue of the nonchalant attitude of people.
And how can we do that?
Is that what you're saying we should contribute on?
Yeah, as in, what do you think now as a person, you now? How do
Mm-hmm.
you think you can, what do you think you can do to contribute to what problem we think we have on ground, and looking at our attitude towards that, in what way do you think you, as a person now, you can influence positively towards the mitigation of the problem we have at hand? Because we've come to understand that, everything we're speaking there is just around what causes global warming and temperature, climate change, right?
Yes, sir.
So what do you think you as a person now, you can say you want to do to help?
Okay, sir, let me speak.
Okay, Akpan is speaking. Yes, Akpan, I'm happy you are very
Okay, okay.
vocal today. Participative. Yes, let's go.
My own part, I think creating of awareness in the first instance will help because most people does not know what is happening. From the knowledge we gain, we let them know this is what is happening in Nigeria and this is the way out of it. From that advocacy, it will really help.
Okay. So Akpan, you think when people know now, how will that help them?
Yes.
How will that help? I'm trying to know.
So if they know,
Yes.
yeah, as we individually trying to contribute to reaching this national, this our NDC, who
Mm.
also contribute their own quota, so that we can actually get this target by the 2030.
So that's the question I'm asking you now. How do you, Akpan, now contribute to this quarter now? Maybe let's take these key measures now. You cannot contribute towards gas flaring, but the second one work towards all three: the efficient generators, 2% per year energy efficiency. Let's leave that one. Transport, shift from transport, improve electricity grid, climate smart agriculture. These other ones you can be part of them. So how do you think you can do that?
Like in the case of transport shift,
Yeah.
I can make use of my bicycle instead
Mm.
of or cycle that uses that emit carbon dioxide.
So first and foremost, do you have one?
Yes, I have bicycle.
Okay. When did you get your bicycle?
I have bicycle when I was in primary school. Because locally, that is our major means of transportation. Now, as
Okay.
I change it to the modern type. That old one, the horse, the type, the one where you have a power horse. That
Yes.
horse, So that was the first bicycle that I have. Though my parents bought it for me, I used it to attend my secondary school. So as I grow older, I have to buy the latest model that helped me to do cycling.
Sorry, I'm going deep into the bet. After teaching a lot of these years, I'm being paid for teaching. But then, if I really don't like, this is my own part I'm playing now. You see, I'm going personal, but
Yeah.
I
Yes.
think it's very important. Akpan, why did you? It's typical of Nigerians to aim to buy cars. So I'm surprised you are upgrading from bicycle to another bicycle.
Uh,
Are you for real?
it based on resources. Even though I still have plans to buy a car, and what I use presently is depend on my resources.
Okay,
So
so okay.
the
Okay, sir, we
the
go on.
the very essence of the motorcycle sorry, is the bicycle is not only it help in the exercise, which is the primary reason why I mostly like using it.
Okay.
I
Yeah,
go.
okay. So I thank God for somebody like Akpan. I'm happy to hear that I'm saying that because let's not just bring up measures that are on paper or on slides as we are seeing them. So but the question is where do you ride your bicycle to? Do you ride it to the market? Do you
I
ride it to
want
work?
to check the distance. Is I don't know. Since I am in a Ibom, is
Okay.
on one occasion I have drove from my village to the state capital, past
Okay.
7 to 8 local governments before I reach the state capital. It's
Okay.
on the Sometimes we move from a left house by 8 o'clock. We arrive at the station by 4 p.m.
Okay.
So
That's almost like an exercise. Is there your day-to-day activity that
was
requires movement that you use a bicycle?
no. I mean that was on that particular occasion. Then thereafter, other ones is just within the my residence.
Which is very important. Only residence. How big is your residence?
It's a town now. It's a town.
No. Your residence, maybe I'm believing is your house. It's a town. So I'm asking you, do you ride to work? Do you ride to the market? Do you ride to go and shop or something like that?
Yes. Market.
Market, good, makes sense. You can decide that there's this market that is like 2.5 kilometers from your house. So your bicycle is solely to be going to the market with, right? It goes a long way to help. Please, are other members of the class with us?
Yes, sir, we're following.
Yes, sir.
Good. So these are really workable measures. And if this class were 20 of us, if 20 of us pick out something and we're living up to that, the effect may be very minute. But if we have like up to 120 classes of 20 that have done that, then you will start seeing that the cumulative effect will now start showing some significance. Okay? Yes, can somebody else
Yes,
try
sir.
one more? Yeah, we can go on.
Stop on
Yes,
it.
sir.
Yes.
Can I go ahead?
Yes, please.
Okay. So on the electricity aspect, uh, presently I use solar in the house. It's not
Okay.
big. I just have two panels with a battery, and
Okay.
how efficient it is. Sometimes you see the whole community, or let me say my neighborhood, there will be no light. NEPA, they don't bring light for like days, a week, and but we will have light, and people will come in and charge. So, I entered a keke yesterday, and he was saying that somebody stopped him and said he should help him for a distance of 500 naira, that he has 100 naira. And the keke man said, I will help you so that you help somebody too. Next time you should help somebody. So, where I see my input is, yes, solar is expensive right now. But if we can have agencies, or even me myself, if I can assist, no matter how little, if it can start with
My
me, because
God, who is this person that is calling me now?
they saw that
Somebody will class with
somebody
that one.
has it. So if me too, I can assist somebody, even if it's with the information or with the benefits or with cash or with where to get, how to get the proper one, because from some of the people that install too, you could get problems with them. But if you know, because once people trust and know that they can get a good work at this person, I think that is a help that you help somebody too. So that will also help to reduce the use of the usual NEPA electricity light. And I have a shop. I've already started planning, saving towards changing the source of light in that shop to solar. I've already bought and right now we have electronics that are solar. They tell you greenhouse something is also some electronics are into that. So I bought a deep freezer recently, very big one that is friendly with solar. So you see that too will also assist so that when I change to solar at the shop, I can, and people, the other shops that are around will also see how efficient that is and will key into it because they've seen, not only heard. So I think that will also help.
Sorry, who is speaking?
Is the work more go back?
Okay, you are not in our first class, are you?
I have been in the class throughout.
All the class, okay. This is the first time I am speaking. I am speaking
Yes,
from where?
I just.
Okay. So
Okay.
go back. Majorly the way you can look at what you are doing and the effect it has is if around your neighborhood, people are like let's say the persons that come to charge phones or use the light in your house are like, let's say, 5 households.
Yes.
Imagine that 5 of them are all blaring their generators plus you six. And imagine what will happen.
The environment will be toxic.
Exactly. So that's so much. Then down to your shop again. Now, if at the shop, instead of people blaring their generators again, they are coming to your shop to, that's the contribution. And these are workable ways. Whether we like it or not, it has an effect. Cumulatively, if people imbibe this to come to help. And that's why the World Bank has instituted these programs, sponsorships, that you are doing these programs for awareness. So, Akpan, what you spoke about awareness is not that it's wrong, it's correct. Okay? Awareness is important. My problem with awareness in Nigeria is people just know it and speak English about it.
Come and eat rice and go.
Yeah, exactly. So, as I speak with you, I have 2 bicycles. Majorly going to work now is either with bicycle, or the only thing that may change my decision of not using a bicycle is maybe the way I dress. Typically on Fridays, like tomorrow, I dress in traditional. You start using bicycle or traditional. It looks funny. So I may not do that. But the remaining days of the week, out of 5 days of the week that I work, almost like 3 of them, I use bicycle to work. Okay. And then evening strolls now, where I may want to go a bit of distance. It is typical of me using my bicycle. Okay. I have a generator, but I hardly, in a very long time now, I on my generator today just because I wanted to charge my system and have this lecture. And as this lecture is going on, the light has come. I've taken it off. Even if it goes off now again, I have enough. I will never. But some other people, hey, no fan, do this one. There's no light on the, So the attitude, not that it's just because you have. That's why you want to on
Mm,
it. You reduce as much as possible. It's morning. I can manage with whatsoever heat is there. Now, maybe later in the afternoon, I can insist, okay, on using fan or whatsoever. Okay? So if all of us
yeah.
find a way, one way or the other, to look at those of us that are farmers, what was that person speaking? Simeon.
Yeah, I wanted to speak too.
Okay, please go ahead. Let me not stop us.
Recently, I got some land by way of inheritance. So
Okay.
my village
Congratulations.
is fast becoming. So at first, I was doing it not with the intention I was protecting the environment. I was just doing it that I wanted to protect my land. I planted a lot of trees, oranges, and palm trees like that. So I think I planted, counting now, there are about 300 stands I've planted. So now
Correct.
with this, I have now known that yes, I'm actually helping the environment. So if all of us can decide to plant trees, I think it will turn our locality to carbon dioxide sinks, and that will help the
God,
environment very much.
God bless you abundantly. That was one of the easiest ways. Now, how many of us where we are living have planted at least 1 or 2 trees?
Did
I
though.
have.
I did.
Mhm.
Mm,
So that's great contribution with minimal effort, self. Because when you
yes.
plant a tree,
Yes.
what do you do? Nothing.
And they're
You just
economic.
pray.
Make
Uh-huh.
money from that
You
standpoint.
pray for rain to fall only. Even if you don't pray, God is faithful. The rain will come, right?
Yes,
Yes.
sir.
The only thing is just guide it against straying animals. Okay.
Yes.
So in one way or the other, let us be seen to be doing. Now, it should get to a point where every year, at the end of the year, as I think when we're doing crossover, you before you go for the crossover, you can decide from December 1 to December 15. Have an assessment of how much you have pampered the environment, and then see how you are doing. Then what happens is, for those of us that work, right, you hope that every year you should have at least a marginal increase in your income, right?
Yes.
Yes.
Sir.
So if you assess yourself last year and you did this much, you should do better this year, right? If it
Yes, sir.
declines, then it's not good. Okay.
Yes, sir.
Yeah. Does any other
Okay.
person have any other thing to add?
Yes, sir. I have, and I also have a small question to ask.
Okay, good. Please, yes.
Yes, me, I love agriculture so much because
Mm.
that's where I get my own food. So, just as I was saying, I'm one of the people that were advocating for this carbon farming.
Hmm.
That is how we call it, carbon farming. So, uh, it has taken some time now that on my field I hardly burn. I
Okay.
do manage the residue on the field, and the farmers that are close to me, they are seeing the difference even with or without fertilizer. The performance of the crops on my farm is always better than what they are having there. And the simple secret is avoiding chemical fertilizers and also managing residue very well. So most
Okay.
of them they are seeing the difference and they are beginning to feel it. So coming to say that,
Otman Idris, mute your mic. Good. Simeon, go ahead.
if they will do this, it will continue it. Hello, sir.
Yes, we can hear you.
Yes, yes. I'm hearing you.
Okay, okay. So just as I'm saying, when most of the farmers see that if they will follow these practices, they will even have good yield, and the cost of production will reduce, and at the same time, at the end of it all, they will be paid an incentive for doing it. Most of them are adaptive. Now, my question is, if you go into residue management, you will discover that in the course of decomposition of this residue, some of them you see that they also produce methane, and methane is harmful more than carbon
Dioxide.
dioxide based on
Yes.
yes based on what we are learning here. Like me, I love
Warming
using
potential, yes.
yes, like me, I love using compost. I love using animal droppings. I love allowing the residue to be on the field. And in the course of the composition, I discovered that they produce a lot of methane,
Mm.
especially those that are related to cow droppings and that of rice straws. So in this case, how are we going to do it? Because to me, I think I'm controlling burning so that I will reduce carbon emission. And in the course of it, I'm also emitting another,
Greenhouse gas.
um, yes, another greenhouse gas. So how are we going to manage
Good
that
question.
situation on farms?
Good question. Good question. Uh, Simeon, do you know ethanol?
Yes, sir.
Okay. I think if I give you this example, it will make more sense to you.
Okay, sir.
There is bioethanol. Have you heard of that?
Bioethanol.
Yes.
Yes, I've heard of it, sir.
What do you think is the difference between bioethanol and just normal ethanol?
So I've not gone deep to check the difference.
What's your background again? Sorry.
Agricultural engineering, sir.
Okay, engineering. So
So
you should be able to
yes, sir.
understand this. Now, bioethanol means ethanol from biosources. What is bio? From life sources.
Life, yes, sir.
And there's ethanol that you can still get from fossil fuels, right?
Yes, sir.
Good. The two of them are both ethanol, but their adverse contribution to the environment is different.
Okay.
Now, bio, that from plants is normally not very hazardous as compared with
Okay.
the one from fossil. So the methane you are producing It's not as dangerous as the one we get from gas flaring, for instance.
Okay.
Mhm. So let your mind come down a bit.
I'm back, sir.
Of course, it is still the same thing, but I'm very sure that if we do an experiment and check even their global warming potentials, they will be different. The same amount of
Okay.
methane that is from agricultural sources, e-sources, and that from fossil fuel sources, they will be different.
Okay.
Aha. So that should just, I think that's just the straightforward answer I'll give you.
Okay, sir.
Mhm. So, like we said, you cannot do away totally with them. These
Yes, sir.
gases, they are as well important, but reducing them to the barest minimum. It is better for us to be emitting, if we must emit, if we emit the ones from biosources and we totally cut the ones away from fossil fuels, then at least the world will be a better place. Now, can I ask you a question? Can you
Yes,
answer
sir.
me? If you compare the contribution of methane from biosources and that from fossil fuel sources, which one do you think will be higher in our Nigerian atmosphere?
Sir?
The one from petroleum sources.
Fossil fuel sources, right?
Yes, sir.
It will be far more. Why?
Yes,
Oh,
yes,
hello,
it will be
sir.
common.
So the activities that bring about those ones from fossil fuels are far, 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 far more.
Yes. Yes.
Okay. So be consoled if it's they are not doing what is so bad. Okay.
Okay, sir. Okay, sir.
Mhm. Thank you so much. Um, can we continue?
Yes, sir.
Okay, so let's
Sir,
look at the ozone layer. First and foremost, where are the geologists, geographers in the class? You remember there's a popular saying that the higher you go, the cooler it becomes.
yes.
Do you remember that?
Yes.
Yes, sir.
You know, it's a geography adage before we now started applying it to other things. That the higher you
Yes,
go
sir.
in life, the more you make it in life, the cooler it becomes. Because it was a geography term. But if you look at
Yes.
it
Okay.
in the real aspect of it, you know, the atmosphere is made up of the troposphere, stratosphere, and then the mesosphere. Okay?
Yes,
Now,
sir.
that thing, that saying is just happens in the stratosphere. Hello?
Yes, sir. We are hearing.
It's applicable in the truth. Sorry, there's a call that's trying to distract me. I know it will likely come again, but this
Okay.
thing is applicable in the troposphere. It is not in the stratosphere. Then it is again in the mesosphere. Okay? Now, but we're trying to understand the ozone layer. The earth is made up of, is made up of the troposphere, the stratosphere, and the mesosphere, right? And
Yes.
temperatures behave differently in these different zones, okay, or spheres, okay.
Yes, sir.
So now the troposphere is the closest layer to the Earth's surface, where what the climate or weather we talk, no, weather we talk about is found. Temperature decreases with altitude. That's the higher you go, the cooler it becomes. Decrease in temperature means cool temperature, right?
Yes.
Uh, While in the stratosphere, what happens? Talk to me.
The temperature increases.
With increasing altitude. Okay. Mhm. So that goes to still explain what happens with the ozone layer. Okay. So the
Yes, sir.
ozone layer covers a part of the atmosphere. Now, when ultraviolet rays when ultraviolet rays from the sun comes from the sun, it will hit the earth, right?
Yes,
Yes,
From the
sir.
sir.
atmosphere. Okay. When that happens, the ozone layer is in the atmosphere, right? Some part of the atmosphere. So
Mm-hmm.
it prevents or protects that direct hitting of the radiation from the sun
Ebo.
to the earth. Okay. So
Yes,
it
sir.
controls it. At the same time,
Okay.
when greenhouse gases are produced from the Earth's surface, right, from anthropogenic or human activities, instead of it to just leave immediately like that, what happens is that the ozone layer has a way of holding them, right,
Yeah.
which causes the greenhouse effect, which is the warming of the Earth, right?
Yes, sir.
Now, so when this ozone layer, it can be, I'm coming. Okay. The ozone layer, through some chemical activities like this, ozone is O3, oxygen gas is O2, right?
Yes, sir.
So the ozone layer is O3. Now, you remember that one of the greenhouse gases I said is fluoro gases, right? Or compounds. So the halogens are part of it. And these halogens can split one, for instance, chlorine atom, like the slide you have in front of you. That free chlorine atom can now react with the ozone. Ozone is actually very stable and inert, but chlorine can react with the ozone molecule and take out one oxygen atom and form the chloromonoxide compound or radical. Now, when one of the atoms of oxygen is taken, what now remains?
Two.
The oxygen gas, the free oxygen molecule gas, okay? Which
Yes,
is not
Yes.
harmful, right?
yes, sir.
But the things that are formed now are chemically active. They are not stable like ozone again. So
Okay.
what happens? That ozone layer gradually is being attacked and then the layer thins out, okay?
Mm.
And so that protective covering that the ozone has over the atmosphere is now being attacked.
Okay.
Now there's possibility of direct sun radiation from the sun to incident on the atmosphere, right?
Yes, sir.
And there's possibility of the greenhouse gas effect. Instead of them being enveloped by the ozone layer in the atmosphere, they can seep out into this other higher, that's thermosphere, exosphere, and the rest. There's possibility
Okay.
of them going out that way, right?
Yes.
That is what causes what the ozone layer can cause. Now, what will happen? The heat from the sun will do us shaggy, right?
Mm-hmm.
and it will still cause global warming and climate change, right? So that's basically the concept of the ozone layer. First, maybe I would have, we spoke about the air composition, right? And what did I tell you about the air composition? That of the constituents of the air, which one is the chemically active one? The major components of the air, air is a mixture.
Yes.
And the major components, they make up 99% of the air. That is what and what?
Oxygen and
Nitrogen
nitrogen.
and oxygen.
Nitrogen and oxygen. Of these two, which one is chemically active?
Oxygen.
Oxygen. Nitrogen is very stable and inert. Okay. So let's take it slide by slide now. Explanation is that all the energies from the sun travels through the space in form of EMR, as electromagnetic radiation, at very high speed. If you say 300 kilometers, 300,000 kilometers per second, that's a lot, right?
Yes.
The motor cars we know that travel very fast. Okay, even the planes between Lagos and Abuja, I think it takes roughly an hour, right? If you compare the speed of the plane, which we know is very fast, or let's come down to the car from Jos to Abuja. From Jos to Abuja, how many hours does it take? How many kilometers? Does anybody have an idea?
On aeroplane.
No. By car.
Aeroplane
By road.
By road is around 300 and something kilometers.
So let's say 300 kilometers, just roughly.
It takes
How
roughly
many,
5 hours.
how many hours does it take?
5 hours.
Say it again.
Average 5 hours because of the road condition.
five hours.
Okay. So let's say if the roads were not bad, can we make it in 3 hours?
Yeah, 3 hours.
But
Yes.
that's mad speed. I hope you know.
Yes,
Yeah,
it's
100.
smart speed.
Mad speed.
So 300 kilometers, 3 hours.
Yes.
So how many kilometers per hour?
100 kilometers per hour.
100 kilometers per hour.
It's more than 100.
If it is 300 kilometers and you do it in
And
3
it's 3
hours,
hours. So it's
that's
close to
100.
200. It's close to
No,
200. It's more than 100. Sir.
no. Really?
Yes, it's more than 100.
1 kilometer. Yes, because it's 60 minutes that make 1 hour. So if you are
Yes.
dividing 300 by 6, yes. So 3 divided by 6, 300 divided by 6. You have like
Stop
almost
confusing yourself. It's still it's 100 kilometers per hour.
100 per hour.
It's still 100 kilometers per hour. What you're
okay,
trying to
yes.
convert it to minutes. So if you do that calculation, it will now be per minute.
It's taking that.
Okay, so it's 100 kilometers per hour. So you see that's a lot of speed. Now, can we compare that speed to this? 100 kilometers per 1 hour. This one is 300,000 kilometers per second.
Per second.
So that's mad speed. That's a lot of speed that cannot be compared with anything on Earth here that we know.
Okay, not all.
So that's how much it is coming. And as long as life is, since we started knowing ourselves in this world, that's what has been happening. Okay. So the deflection of the solar, this radiation is due to clouds, dust, vapor, gas particles. So even the greenhouse effects, greenhouse gases, they come. So when something is incidence on a plane, what happens? It's either it's absorbed or it is reflected, right?
Yes.
Deflection is a way of reflection. Okay, good.
Yes.
So this reaches the earth and is absorbed, reflected back, and water and all of that. And some is absorbed, okay, converted into IR waves, which keeps the sun on the earth warm. Now, all the 3 we spoke behind is what is showing here now. Okay? You can see the incoming radiation from the sun. Let's assume it is 100%, right? 51% of it is absorbed by the Earth's surface. 19% it is absorbed in the atmosphere by the gases, the clouds. Clouds is still water vapor, right? Made up of other gases
Yes,
as
sir.
well. Uh-huh. Then 30% of it is being reflected by either the surface of the earth, the same clouds which is hitting, and even the atmosphere itself. Okay? So the atmosphere itself reflects just about 6%. The earth's surface reflects about 4%, while the clouds, the gases, the vapor, and all of that reflects 20%. That's what uh, this slide is showing. Okay.
Okay, sir.
So you can now see that with this now, it explains further. So this is one of the rudiments and the fundamentals that explains how the greenhouse effects or the greenhouse gases are in operation in the atmosphere. Okay.
Okay.
This is still the same thing. Okay. Just like we saw behind, heat, electromagnetic radiation comes in the earth, some in the space are being they are visible to the eye whatsoever. Then greenhouse effect. I've explained this before. Okay. So now let's look at the ozone layer depletion. We've explained what the ozone layer is, and it's found in the lower part of the Earth's atmosphere and all of that. The ozone layer depletion is the gradual thinning of the Earth's ozone layer, right?
Yeah.
In the upper atmosphere, caused due to the release of chemical compounds containing gaseous halogens. It's not only bromine or chlorine, even fluorine from human activities. Okay?
Yes, sir.
Yes.
This happens when the chlorine, well, I think I've explained that,
Yes,
haven't
sir.
I?
You have.
Just
You have
Yeah, I've
like
explained
that
that.
diagram.
Uh-huh. Once chlorine can destroy up to 100,000 molecules of ozone. One chlorine radical, it can destroy as much as that ozone. So it destroys more quickly than it is created because the ozone can also be gained back. It can recreate itself. Do I call recreate? No. Can re-get itself back through chemical activities. Okay. So, but you can see that. Okay, let me ask you
Oh,
another question and then use that to explain something.
maybe I'm not
When they write chemical equation and there are two arrows, one half arrow pointing towards the product direction and one other arrow pointing towards the reactant direction. What does that mean?
it's a reversible equation.
Redox.
Let
Redox equation.
me hear plenty things. Redox, reversible, what again? Is this Simeon that is the chemist?
Sydney too.
No.
Sydney.
Yes, sir.
Sydney, talk to me. Talk to us, not me.
It's a reversible equation. It can happen either ways, back and forth.
Okay.
Alright. I see also for you that I talked to him, the thing is a man no final.
Ah,
I'll
please,
come
you
back.
should tell Idris. So, what this person here now is important. So, he said it means reversible. Is that the only thing? Only what it means? There's more information that gives. And what is that? It means that the rate of production of the products is the same as the rate of the production of the reactants. So when you check the amount of products in that system and the amount of reactants, they are the same, right?
Yes, yes.
Yes,
So
sir.
for a reversible reaction to carry those things, it means that for there to be equilibrium, that means there's an equilibrium in the production of the products as well as the production of the reactants back. Okay?
Yes.
Yes.
So now, but a situation where there are more products formed, what happens? Sometimes you see in some textbooks where the other arrows pointing the other way is half. Have you seen that before?
The equilibrium will be
Yes.
So in a reversible reaction situation, when there are more products being formed, you see that the arrow pointing backward will be like half, right? So
Yes.
that's what explains what is happening here. Normally, the ozone layer is supposed to reget itself back. It's supposed to produce itself back from still the activities in the atmosphere of gases. It's happening, but the rate of depletion is more than the rate of creation back. So that's where the problem of the depletion of the ozone layer comes up. Okay? And it's getting scary. Okay? Now this one shows
Yes.
the plenty English I've been speaking. So these are chlorofluoro gases or compounds. Okay? And where do we find these things? Domestically, you find them in refrigerants and all of that. So you will notice that now they are not using or halogenated carbons as refrigerants again. In ACs, fridges, deep freezers, they have started using cyclohexanes and all those other hydrocarbons. Okay? Because in the use of these compounds now, for any human activity, industrial activity, there are possibility of these things coming into interaction with the ozone layer, thereby depleting it. Okay? And this one just shows how these atoms, halogens, majorly chlorine, can go out to attack the ozone layer, right? Thereby forming the chloromonoxide and the hydrogen oxygen molecule. Okay? This thing still further shows, it just stresses what happens. Okay? And this happens in the stratosphere where the ozone layer is. Chronologically, just shows that the UV causes a chlorine atom. So, for the chlorine atom to split out and become a radical that is very reactive, and then in the second stage to be able to attach itself to the ozone
Oxygen.
and then cleave one of the oxygen atoms and form the chloromonoxide and the oxygen molecule now comes to play. Okay? Good ozone and ozone hole. So we've heard of the holes in the ozone layer, right? So 90% of the ozone is in the atmosphere and it sits in the stratosphere. Between that 10 to 50 kilometers altitude, right? The natural level of ozone in the stratosphere is as a result of the balance between sunlight that creates ozone and chemical reactions that destroy it. We've looked at those reactions. Ozone is created when that kind of oxygen we breathe, okay, is split apart by sunlight. Of course, the ultraviolet radiation has energy. They can split an oxygen molecule, okay? And that free oxygen atom, right, has the capacity or the potentials to further react with an oxygen molecule to form back ozone. Okay? So I've explained to you how ozone can be destroyed into oxygen molecule. And likewise, if you look back at this, you see that there's a free chlorine at the fifth stage. There's still a free chlorine radical that is splitted out of the chloromonoxide. giving out one oxygen atom, right? And that one can still recombine with an oxygen molecule, or yeah, oxygen molecule to form back your ozone. Okay. The total mass of ozone in the stratosphere is about 3 billion metric tons. And this may seem like a lot, but 0.0006% of the that's 0.6 of the atmosphere. The peak concentration of ozone occurs at an altitude of roughly 32 kilometers. That's 20 miles above the surface of the Earth. That's where the ozone layer is. And at altitudes, ozone concentration can be as high as 15 parts per million. That's what 15 parts per million means. The ozone hole is not technically a hole, right? But it's just a thinning where no ozone is present. There is actually a region of exceptionally depleted ozone in the stratosphere. Depleted does not mean that it's totally finished, right? Over the polar regions, that's between August and October, fluorocarbon are not assumed to in the reaction, but remain in the stratosphere to continue the destruction of the ozone layer. So, like I was explaining, it is being destroyed, it is being gotten back, recreated back. But the scare happens because we are getting more of these compounds that causes the ozone to be reacted and depleted. Okay, that's where the problem comes. So ozone can be good, but the ozone hole is a problem. So that's just a picture to show, just a pictorial, mental assumption of how the ozone layer can be depleted. In some cases, not so it's not all around the seal. Just a little part of the seals are perforated. Okay, that's what is referred to as the ozone hole. So this is just a picture that shows what we had explained before, where I showed the percentages of ozone. So the causes of ozone layer depletion, can we speak about them? I explained the chlorofluorocarbons. Those are the major culprits, right? And we have explained how they chemically attack the ozone layer. Now, there's a popular saying that, how do I put it now? Supposed to be an African saying. But what does it mean? It means that even when you are not well to do, there are advantages to it, right? For those people that have generators, it's a blessing, is as well a curse, right? Because that's where they will start gaining, they are exposed to a lot of very dangerous gases, right? Now,
Yes, sir.
elsewhere in developed societies, where they launch a lot of rockets and all these satellites, what do you think happens? These rockets will go through that ozone layer, right?
Yeah.
And they are propelled by fuels that burn too. So they are going to create, whether, even if it's a gas, you must penetrate a gas before you pass, right?
Yeah.
Yes.
So at that speed and the mass body of the rocket still creates ozone layer depletion with the gases that it expels during motion. Okay? So unregulated launching of these satellites, rockets, and all those things that can be launched at high speeds can cause ozone layer depletion. And if not controlled, it has been projected that this might result in a huge loss of the ozone by the year 2050. What do we say? God, I beg you, let it not be in our lifetime. Abi?
No.
Our children go suffer am, sir.
But we're looking at 2050 now. It's not far again, 20 something
Yes.
years.
It's
It's
not.
not far.
All things being equal, in the next maybe 25 or 30 years, let's max, not up to 30 years. All of us will
Yeah.
still be alive.
Wow,
Yes, sir.
No.
amen.
Yes.
by the grace of God, sir.
Yes, so we'll be alive in the
Do we
next
have
40 years.
anybody that is up to 60 years here?
No, me, I'm not up to that.
No, is there anybody that is up to 60 here?
60.
No.
So even if there's somebody up to 60, in the next 24 years, you will just be 84.
84. Yes.
And you shall be living in Jesus' name.
Like
Amen.
Tinubu.
Amen.
So, God, I beg, let it not be our time. So, at least, do we now pray that Nigeria should not technologically develop so that we will not witness these things?
50-50.
We'll pray for that.
That
We
we
are
will
caught in
develop.
between. We are caught
Yes.
in between because we need that too. Nitrogenous compounds, natural causes can cause all of that. Volcanic eruptions, earthquakes that brings up a lot of things, okay? So it's not only us that will cause wahala about the ozone, okay? And these are the causes, the sources, the polluting substances, and their sources. I told you that the chlorofluoro are gotten from refrigerants that are used in refrigerators and other cleaning agents, right? You get halogens. You get them from fire extinguishers. You notice that everything here are halogenated compounds, right? Carbon tetrachloride, that's CCl4. Cl is a halogen. Methyl chloroform, CH3Cl. They are all halogenated compounds, okay? How does
Yes,
the
sir.
ozone layer grow? If you read through it, you'll get. But we've spoken about how it grows again. Constant activities that causes it. If they are up, it will continue to grow, and how it can be saved. Look at it and get it. Okay. If you read through
Yes.
that, according to simulation models, it is estimated now that we know how all these things work. Sorry. It is estimated that the ozone layer will be mostly recovered by 2040.
Okay. 2040.
Even if we don't slow down our activities that are destroying it.
So, sorry?
Even if we don't slow down the activities that are destroying the ozone layer, it will
And
still
that's why
be.
with all what people are going to COPs to sit down to look at things. The major contributors to the world's metric ton development of these gases that are causing these things. They are deliberate about it. Okay?
Okay.
So that's
All
why
right.
they are
They're
simulating
trying to mitigate.
that something that will contribute, okay, by 2040.
All right.
2040.
I'm sorry I'm saying this, but Kai, some of these things is just to paint them so that they will sound good. Let it not be that they've collected is happening. So that's why I suspect that they are simulating all these models. But I hope you know simulations, not all of them happen just the way they are simulated to happen.
Yes, of course.
Engineers, are you there?
Yes.
Uh-huh. So effect of ozone layer depleting substances, so, it can cause things like cancer. Those are the health effects
No.
now. You know, gene mutation.
Yes.
Those kind of things can happen. Okay. You have the health effects are overwhelming. We can look through all of that, okay? How to avoid ozone layer depletion. There's no need to speak about this. We know what to do, okay? We have spoken about these things over and over. So now we'll look at the acid rain. Any question on ozone layer? Any question? Let's try and rush and finish the acid rain. It's an interesting one too. No question.
No
There's
question,
no
sir.
no question. Okay, so let's look at acid rain quickly. Uh, so if you remember, we spoke about the acid rain. Now maybe we may not follow the slides, but we'll just do acid rain. What did I tell you was the cause of acid rain? Do you
It was
remember?
as a result. Yeah, it was a result of the toxic substances in the atmosphere mixing with the
Mm,
water.
Noxes, oxys, and all many other uh, gases in the atmosphere. Now, if you look at the picture on the slide, can we speak to the picture? Do we understand it?
Yes, yes.
Yes.
Okay. In a nutshell, somebody should try to explain. Now, let's all listen, right? Let's
Yes,
all
sir.
listen very well. When one person speaks, another person will go in and say, okay, this person has spoken that feel they left out this now. And then you now bring your own. Then a third person like that, you will speak to this slide now, finish speaking to it. Let's go. Who bells the cat? Who goes first?
So let me try.
Okay. Yes, Freda.
Yes, sir.
I can see you have freedom now because you have finished with your director. You have finished your briefing.
Yes, sir.
Okay.
Thank you, sir. Good morning.
Yes. Good morning.
So, so this oxides, that's the soxys and the noxys that have
But
been
we are
in.
looking at. I hope you are looking at the
Yes, I'm
slides.
looking at the diagram, sir.
Okay.
So, as they are being released from industrial activities, as you can see from the diagram, they
Mm-hmm.
now move up to the atmosphere
Mm-hmm.
and now react with the atmosphere. That's
Mm-hmm.
react with water. That's the cloud.
Mm-hmm.
Then they are now
Released.
released. They are now released as rainfall to
Mm-hmm.
the earth, which already have actually polluted the rain,
Phytochemical.
the actual rain that we're supposed to have. So it's already polluted due to that reaction with water, oxygen, and sunlight. Although no sunlight here, sha. After reaction, they now pollute the rain that is supposed to fall naturally, causing it to be acidic to the earth.
Okay. Any other addition to that?
Okay, sir.
Yes.
So from my observation on the picture, I see that the polluted water, just like she explained from the beginning, I'm just speaking where, just to add
Mm.
on to what she said. I
Yes.
see the pollution coming as rain directly on the plant, and then I see the pollutant in the air, not in the water now, in the atmosphere, coming down to the dry land.
Okay.
So it falls on the two ways, not only on plants but also on dry land, and it must not necessarily, it's not coming only through the cloud, rain. Is
Mm.
also in the atmosphere and falling on the land.
Okay. That's great. Good observation. Yes. Any other person? Simeon.
Start.
Okay,
Sir,
Sydney, let's go. Yes, you're a chemist. You should talk.
there is also the sources of this NOx is coming from natural sources.
Okay.
Yes.
Plants giving out human beings giving out carbon dioxide goes into
Mm.
the atmosphere, as
Even
shown in the
natural
diagram.
disasters. Uh-huh. Even natural disasters. That thing showing the second source of NOx there. It's not volcanic eruption.
Yeah, that's about
It is.
NOx.
Mhm. Uh, so I think there's something missing in this picture. If there was a water body, what do you expect?
Evaporation.
Evaporation.
Evaporation that causes the precipitation. Precipitation is rainfall, right?
Yes.
Yes.
Yes, sir.
As well. So now the whole ecosystem becomes acidified, right? And it's not
Mm.
everything that is good to be acidic. Some are supposed to be basic, right? It
Yes.
pollutes our
Yes, sir.
agricultural lands. It makes the water body acidic, and it can affect the bio elements of the water, or let's
Yes.
say of the ecosystem, right?
Yes.
Well, it's not everything that there are some that enjoy the acidic nature, but some don't, right? So, what are the effects of
Yes, sir.
what can we say are the adverse effects of acid rain?
It kills aquatic animals.
Exactly, can kill aquatic animal. It affects, so you can see that acid rain even affects biodiversity, like we're talking about, right? Good. So
Yes,
the
sir.
effects are plenty. So if you can understand this, so this is a more complete diagram that shows success, noxis, the foxes, acid rain, how it affects the water body. You can now see that at the right hand side, you see that the trees are withered, right? It tells that maybe these particular trees, they don't enjoy the acidic nature of the soil at that moment, or the water body that is feeding it. Okay. And it can as well cause adverse health effects, right? People like
Yes, sir.
Yes, sir.
us that would like some very funny kind of foods.
Yes, I want to go
I
and
like.
do this. I want to go to their unit. I'm in my unit. After in the next 2 hours.
So yes, Agatha, your director was speaking, right? So you see that somebody like me that likes cricket a lot, it may have an effect on how crickets are, because if the place becomes very acidic, they may not be able to live well again. Okay, so that's just an example of how carbon dioxide gas causes acid rain. Okay, it reacts with, you see that carbon reacts with water and produces that carbonic acid. Okay, carbonic acid. Now, the second part of the equation there, you see H2CO3. How do you know it's an acid? It shows how it can partition into the
Hydrogen.
hydrogen, proton, and then the nitrous oxides too, the molecules. It just shows how the chemical reaction that happens with water. Okay, it first reacts with oxygen in the air, produces NO. And then the NO and the NO2 can react with water to produce HNO3. Okay? The same thing with sulfuric acid is produced from the substance SO2. And that's how it just goes. Okay? And what are the causes of acid rain? So this one just tells that what are the things that causes this, or that the things that cause these gases to be expelled into the atmosphere. Coal power plants. Why do you think coal power plants will cause acid rain? Coal. What's the major component of coal? Carbon, right?
Yes, sir.
Yes,
Yes.
sir.
So if it is burnt into the atmosphere, if there's carbon in the atmosphere, what will happen? It will bring about the COXes, CO and CO2.
Yes.
And when water comes in contact, just like the reactions we looked at behind, it will produce acid rain. Burning of fossil fuels. Akpan, are you there? Akpan.
I'm with us.
So you are in the Niger Delta area, right? So a lot of burning of fossil fuel gases from production processes can cause acid rain, right? When you are flaring gas and you burn, if when methane reacts with oxygen, what happens? It gives about the COXes, right? And then it can cause acid rain. Then in vehicular combustion too, you can get noxes, SOXes, and then acid rain. Now, we don't have time, but let me just ask briefly. What do you understand by sweet crude?
Hello.
Really?
Sweet crude.
Sweet fruit.
Crude oil, the one that is sweet.
Okay,
They
okay.
call it sweet. It just means that the one that does not have sulfur in it.
Yes, this is the type of crude that is produced in Nigeria.
Yes.
Yes, it does not contain high content sulfur.
High content of sulfur, right? So why is sulfur not very good? Because if it is contained in the oil we're using, combustion of sulfur, it will bring sulfur compounds into the atmosphere. And once the atmosphere is involved, what is the chemically reactive gas in the atmosphere? Oxygen, right? When oxygen reacts
Oxygen,
with
yes,
sulfur,
sir.
what do you get? It sucks.
Sulfur oxide.
Aha. So even volcanic eruptions, you can see that we saw something like this. Volcanoes produce, I know, right? So we expect that those are the causes. Then nuclear radiation, okay? You can read through that. Deforestation, it can lead to deforestation. If you notice, we look at this picture here, where some trees are withered by the right-hand side, right?
Yes, sir.
It is going to lead to these trees dying, and then it can cause deforestation, right? It has health implications, right?
Yes,
We
sir.
have enumerated a few of them before. Soil degradation, damage to the vegetation, trees, and whatsoever. Okay. Aquatic life. I think Agatha mentioned that one at some point. Acidification of surface water, corrosion effect. Now, when metals come into contact with acid environment, what happens? It causes corrosion, right?
Yes, sir.
So you
Yes.
now discover that even our manufacturing industry that use heavy steel and all of that, they get corroded. Okay. So these are pictures that are just showing the effect of
Green.
acid rain on the soil and maybe on vegetation. Okay. How do we stop acid or prevent acid rain? Can somebody answer us? By heeding to the
Yes, mitigate
things
it.
that are trying to reduce mitigating the sources of this that we have elaborated. Okay.
Yes, sir.
Regulate emissions, restrict the use of fossil fuels. Which is the most important? To me, the most important is the one that we have imbibed as a lifestyle. Like Akpan rides bicycle to the market. That's the one you can do, right? You don't need to. They don't need to carry cane and be following you before you now meet you start doing the things that should do that. Okay. Use of low sulfur fuels, maybe used in coal production. Use of low sulfur fuel. You know, that's why Nigeria is misbehaving. They have sweet crude. So people, the quality of the crude we have is good. So people are buying it. That's why we can be doing corruption the way we want to do. And then we are sure that we will still get markets. Okay. So any question in the afternoon, we'll look at hazardous materials and then biodiversity. Okay. It's quite an interesting thing. Okay.
Okay, sir.
Any
Okay.
questions? Any question? And in the absence of any
Yes, sir.
question, I think did I give an assignment to you people before?
Yes, you did,
Yes,
sir.
sir.
You said we will discuss
Sir.
it, but you mention it again.
Sorry?
You gave us
You
something to
said,
look at in this class.
Yes. Okay. This afternoon we'll try and rush and listen to them. Okay.
All right, sir.
okay.
Yes, sir.
Thank you so much. So, do we exit the class earlier? No. So, can somebody just take a recap? Quickly. There's supposed to be an OD here. OD. A man introduced himself that first day only. I've not
Yes,
heard from him. Is OD there?
yes.
OD, please, can you take a recap? Or maybe you'll try another time. Not today.
Yes, I think let me try another time. I'm still getting to catch up more because I missed up. My
Okay.
network messed me up the other time. I wasn't really catching on much, so I'm just getting to catch up more.
Okay.
Give me time.
So
more.
I'll try to release more of the materials to you people now. Okay?
Okay. Okay,
Uh-huh.
sir.
Yes, sir.
This is the most important thing is everybody should be following. And I'm happy. I think I must make this comment. The class has been made lively by people like Agatha, Freda, Simeon, Sydney, today Akpan, what was this other? Okusa wanted to be part of it, but did not. Dorcas, I don't think you are here today.
Hello, sir. I'm part of.
Okay, Shadrach, I've never heard you speak before.
Go back to spoke today, sir.
Sorry?
I said go back to spoke today.
Okay, yes, that's true from Jos. Those are spoke today from Jos. Okay. So it's nice having you around. So I'll see you by 1. I hope the network permits us. So meanwhile, how did you go with the other lecture series? Please, there's noise now. There's noise. There's noise. Please,
We had
somebody
the
should mute
lecture
their mic.
yesterday, Professor Andy. So it was a very interesting session too, sir. We enjoyed it.
Okay, that's great. It's
Thank you,
nice to
sir.
hear that. Yes, he's my Oga. I know he will do justice more than me. So you can be sure. Thank you so much. So I'll see you in the afternoon.
Thank you, sir. Thank you, sir.
Thank you, sir.
Okay, sir. Thank you.
Thank you, sir.
I know follow the lecturers complained. Say I wanted to follow, but I later know. I don't know why. How did they observe very well like that? They say now it's concentration. I say me, I wanted to follow.